begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly.
Hello everyone, welcome to this innovation feature. My name is John Howard and I'm the moderator for the presentation, which is entitled Wastewater Pumping Innovation, S-Tube Impeller, presented by Ryan Pearson from Grundfos. There will be a short time for questions and answers at the end of the presentation. The presenters' details will be shown during the Q&A session should you wish to contact them for further information. Please post your questions using the Q&A button in Microsoft Teams. We will deal with as many questions as we can within the available time. Okay, so thank you, and I would now like to hand over to Ryan Pearson. Ryan, can you please share your screen?
Good morning, everyone, and welcome to the Water Equipment Show. Obviously virtual this year, like everything else. So I hope you get as much out of it as you normally would, or you possibly can. It's certainly a different way of doing things, but that we can only do our best in the current circumstances. So Ryan Pearson, I work for Grundfos Pumps. I'm the business manager for our UK water utility team, and I predominantly look after our water companies in the south of the UK and all of our framework contracts therein. The predominant part of our business in that part of the country is in wastewater, and I've been involved in Grundfos Wastewater since we aggressively entered the UK market around 8 years ago.
Hi, Ryan. I can't see your screen yet. I don't know whether you've shared.
I have.
Oh, right. Okay. I can't see it. Can you just check that you've got the red border around your...
Oh, hang on. Yeah. There we go. How's that?
That looks good, Ryan.
There we are. There we are. So now everyone can see my face. We have no video today, so I kindly put up a photograph so that you can all see. So you only missed the title picture, so not very much. So for those of you who may not know Grundfos, so I'll tell you a little bit about Grundfos. So Grundfos are the largest pump manufacturer in the world by volume. We produce over 16 million pumps every year and employ over 19,000 people across the world. And that in the UK, we have a sales organisation and a manufacturing plant in Sunderland. Something that is unique about Grundfos is a foundation still. That means we're not shareholder owned. That gives Grundfos the flexibility to invest as many of its profits as possible, either back into the company or into global development initiatives. And at the moment, we're focusing our efforts on the UN Sustainable Development Objectives, and that's focused predominantly on clean water and sanitation and climate action as our two headline societal goals that we want to impact as part of our foundation. So Grundfos Wastewater, we are, I think, now a trusted wastewater partner in the UK. We're now on most of the UK wastewater frameworks, and the frameworks that we have and the partnerships we have been created around outcome-focused delivery models and aligning our objectives with key regulatory metrics for the UK water industry, and that's where we're trying, in line with the sustainable development agenda of our organisation, we're trying to align ourselves to delivering on, reducing the environmental impact of wastewater and making it a more sustainable industry with our innovation and our products, and that's very much what we're trying to do when we talk about innovation in wastewater. So what does that mean for wastewater pumps? Well, pumps are the largest consumer of energy in water companies. That gives them a very high operation costs. They're also a big environment risk. When pumps go wrong in wastewater, we tend to pollute. That has huge customer impact. But also climate change is adding to the challenge of typical wastewater transport systems, in that we're seeing much more variable demand, much more frequent storm events, heavier downpours over shorter periods of time, more flooding incidences and the like that we see all over the news. And we are aware that as a key supply chain partner, we need to be able to help to impact those things. So what have we been doing with our clients? Well, here's some numbers. So typically with our wastewater pump innovation, we're reducing kilowatt hours of wastewater pumps by up to 37.5%. We're reducing man hours, which is we're using as a measure of reliability, by 71.6%. So we're reducing the risk of environmental incidences occurring. We're reducing waste removal. That's tankering. Tankering is very expensive. It leaves a big carbon footprint, and we're keen to reduce that. But increasing asset availability. We aim with our customers to achieve 95% or more assets available at any one time. And how does that link to what the regulator is saying? These are some of the focus from areas from PR19, and I won't dwell on them too much specifically, but they're really pointing to resilient pump systems, reliable pump stations with reduced risk of failure, pumps capable of managing a variable demand, i.e. managing climate, and effective pump maintenance programs. But crucially, they're doing that with, they want us to do that all with cost efficiency. So they want more for less. They want us to be more efficient and more effective. So what's been happening over the years in wastewater transport? Well, we've seen a marginal gain efficiency curve over the kind of past 20 years. And this is what it's showing here. So, in the early 1990s, there was lots of new impeller innovations being brought to market. Once the impellers had kind of been refined, we started to add on equipment such as variable speed drives to try and increase efficiency. We then added things like PLCs, clever controls, etc., and then monitoring more recently. Now, all of those things have given us, or all of those innovations have been marginal. They've given us marginal gains, but what that's also done is significantly increase the cost profile of our wastewater transport systems, both from an investment point of view, but also an OpEx point of view. Obviously, more components require more maintenance, have more modes of failure, and all of these things lead to cost. So what we did when we brought our S-tube technology to market was we tried to reverse that. So we tried to increase the efficiency but reduce the costs. So we wanted to do something, innovate in a more radical way that reduces power consumption, reduces maintenance costs, and reduces investment costs while increasing the efficiencies of the systems. So what can we do with the pump to deliver those objectives? And that was to bring the S-tube impeller to market. And some of those numbers I showed you earlier was very much the realization of that, the benefit of that innovation. And that was brought to market in 2012. And as I said earlier, it's been implemented in most of the UK municipalities, but it has been quite narrow in its scope because of the range that the S-tube impeller fit on in the market. So this is really giving you an overview of what that range was, and the S-tube was predominantly used in this zone here, in Zone C, with the kind of back end here of Zone B and the area here of Zone D for some time later. But what we've seen in the UK market is there's a high demand for the left hand side of area B and this area here, area A, which is what we would call the high head or super high head area. And the S-tube that we brought to market in 2012 was not available to operate in that range. So now what we're bringing to market this year, and it has launched at the start of this month, is a new S-tube hydraulic that we call the open S-tube hydraulic that will cover this area of high head and super high head range. That's there. So what we want to do is obviously retain the S-tube benefits. That is a wastewater impeller designed for very high efficiency without compromising on reliability. That means it still needs to block less, it still needs to be reliable, it needs to maintain its wire to water efficiency, and it needs to achieve that without complex additions to the systems. That's what we achieved with the original S-tube launch, and that's what we need to continue to achieve with the range extension. And we do that with the market-leading features that we have that our customers like, things like the plug-in cables, the band connections, and the seal ring technology for serviceability, which drives the sustainability of our range, in that we are trying to make sure our customers aren't throwing away our pumps or running to fail. We want them to be serviceable, and part of that is the seal ring technology. So we need to retain all of that, but also be able to impact a larger percentage of the available market, meaning we had to be in this HT, SH, high head, super head range that is quite predominant in the UK market. So typically with the HT, ST, SH range, we would have offered a vortex type impeller for that application, which is fine, but there are known limitations with the vortex range. One being efficiency. They're not very efficient at all, so they're quite high consumers of energy. So that was one issue, and then secondly, the flow rate limitation. You know, they're not able to handle particularly high flows in high head applications. So we needed to address those two things, and that's really what the range extension does with the open S-tube hydraulic that you can see here, with two versions, one without a guide pin and one with a guide pin. And really, again, just to point out that the background into extending this range is to ensure we have the full capability to extend our existing value proposition across a wider range of applications, to drive our sustainability agenda across all of our products, So that's making sure we have a serviceable offering, and to offer a premium alternative to our Vortex pump range. So where energy costs take precedence, then we need to be able to have something that can operate in that part of the market. So the extended range retains the core tube innovation. That is, we try to not disrupt the flow of media through the pump housing as much as possible. We try to reduce the number of vanes to keep wear rates as low as possible. So we retain that in this impeller design, making sure that we still have market-leading efficiency, we still have the optimum non-clogging capability with high reliability and very much reduced wear rates to make sure that we are meeting our objectives that we set ourselves for the market. So the design you can see here in this picture, it still retains the shape of the tube as it flows through the pump housing. But what we do is we remove the shroud from the bottom of the impeller and replace it with this suction cone here. What does it mean from a technology comparison point of view? Well, there's two comparisons here. So the comparison here on the left-hand side is the new Superhead S-tube pump, and on the right-hand side is what we would have used previously from the Vortex range. You can see the duty point is the same, around 15.5 litres per second at 30 metres. And you can see here the main metrics, so P1, P2, pump efficiency and overall efficiency, and the gains are quite clear to be seen. So we see a reduction of 26% in input power, a reduction of 30% power at the shaft, and an increase in efficiency of 25 percentage points. So you can see some quite solid numbers in terms of us realising those benefits of the existing S-tube range, but within the broader market application. To reiterate, we still retain the benefits of the existing S-tube technology. So one of the big features and benefits of the original S-tube pump was the flat efficiency curve, increasing the operating range to 55% on any individual pump, which reduces energy costs, but also gives us the flexibility to reduce the number of model variants. So we can reduce stock holding, for example, and many of our clients already taking the benefit of that. To retain those flat efficiency curves, which increases reliability, reduces energy costs, and enables the pumps to cope with a variable demand in terms of dealing with storm events. Operating at that better efficiency points reduces wear rates, and with the technology that the tube offers, this increases serviceability. So one of the big things for our sustainability drive is we want to move away from run to fail strategies, and we want to make sure the pumps are maintainable. So with the existing S-tube, we said that when the pump hydraulic had been serviced, it had to come back to near enough as new performance in terms of flow, pressure, and power and efficiency, and that was achievable with the original S-tube range, and is still achievable within the range extension. And we maintain the low vibration levels, which further increases efficiency and reduces wear rates. So we achieve all of those things while increasing cost efficiency. That is not adding add-ons such as drives and complex control systems. So back to what I think is important. Resilient pump systems equals reliable pumps, and to make reliable pumps, we have to be innovating in the area of wastewater pumps, and that is an area that the market has been struggling with, certainly over the last 20 years, and we need to keep on innovating with the pumps themselves and not just adding on extra costs to deal with the changes in the environment. And hopefully we're doing that. We need reliable and serviceable pumps to reduce the risk of wastewater pollution incidences. We need pumps with a broad operating range to be able to be capable of managing a variable demand. And the flat efficiency curve model has proven itself to be a good tool in the armory to be able to deliver that, and we maintain that. And effective pump maintenance programs to reduce asset health and to increase asset health and reduce unplanned outage. Pumps that are designed to be serviced. So pumps that we can maintain, that when we do a service activity and buy spare parts, it means the pump returns to its as new operating performance in the context of flow, pressure, power, and efficiency. And that's what we continue to deliver. So what we have achieved is all of those things, and these are the numbers that I shared with you earlier. You know what can be done, and this is what we have achieved and continue to achieve with our innovation of the S-Tube impeller in the UK market, all with increased cost efficiency, crucially. So 2 quick demonstrations now. So an example is a pump station here where we've replaced 2 existing pumps with 2 pumps of S-Tube technology. And these are the savings that were achieved. £6,720 a year on a small pump station. Calls before per year, 32. Man hours before per year, 256. We've reduced those calls to 8 per year and reduced the man hours to 64. Total savings there, 9,600. So we're saving £16,320 per annum on that pump station. And there's a statement there from the field team manager. You know, we quickly realised the opportunity to increase performance, reduce the chance of clogging, whilst considering all other cost-saving implications. We estimate that £16,000 in maintenance costs alone have been saved in 1 year. So that's an example of where the technology is being implemented and how we're using innovation to deliver on the requirements of the customer and regulator. Here's another one, another dry well pump replacement. So project drivers improve asset reliability and cost efficiency. That is reducing blockages, reducing maintenance visits, reducing energy consumption, and reducing external cleaning. So S-Tube dry well pumps installed, achieving a more resilient pumping system with a low investment cost, driving significant reduction in OPEX costs, and not putting in costly add-ons such as velvetory drives, complex control, or other mechanical devices designed to support waste removal. This is really, what we're calling going back to basics. Making the systems as simple as possible. Which drives serviceability. We're not just innovating with our pumps, we're also innovating with other solutions for the wastewater market. Some of these we've been speaking about in other forums. Just to give you a bit of a flavour for that, we are launching what we're calling the wastewater booster station to market. That's what you see here, and that's very much looking at ways to reduce the investment costs and footprint of conventional wastewater pump station designs by eliminating the need for catch pits, which reduces the risk of odor buildup, reduces energy costs considerably, because instead of losing the kinetic energy created by the pumped media by catching it in a pit, we're retaining that kinetic energy and using the booster system to just effectively power it up and move it along, which uses less energy than catching it and starting the pumping process again. And we're also looking at software solutions. I'll be talking about the software solutions for wastewater in tomorrow's main conference. That's Wastewater Network Connect, which is looking at software, algorithms, AI, machine learning to drive better data in wastewater pumping systems, enabling more predictive and less reactive actions for our customers. So that's the wastewater innovation from Grundfos. If you have any questions, then please share them now, or alternatively, I will be in the exhibition booth for most of the morning today and most of the day tomorrow. You can come and grab me in there, or you can get hold of me on the contact details on the screen now. Thank you very much.
Hi, Ryan. That's great. Thanks. Let's get into the Q&A. We don't have a great deal of time, so the first question that's come in is an anonymous question. It says, how does it deal with excessive non-flushables?
So one of the things we were keen to do was make sure that we had as higher level of free passage as possible through the hydraulic. That's why we keep it as open as possible and keep the vane numbers at a minimum. So certainly for the low head and the medium head, the vane number is 0, i.e. we don't have any vanes at all. What that does is allows anything that enters the pump suction to pass freely through the port and the pump housing. So in theory, unflushables, there's nowhere for them to catch, nowhere for them to bind, nowhere for them to start clogging the pump. Certainly for the range extension with the high head and super head applications, we have had to input some vane technology, but what we've tried to do is increase the length of the suction port to maintain the velocities and reduce the risk of any non-flushables catching.
Excellent. Okay, we've got another question here from Mark, and Mark says, how does this new variant perform when pumping sludges? What is the maximum thickness in percentage dry solids it would be suitable for?
So for sludge, for the low head, medium head S tube, which has no vanes, the maximum dry solids would be 6%. For the extended range, the high head, super head, the maximum dry solids would be 8%, because there's vane technology in that, which makes it easier to pump.
Okay, brilliant. The next question is, roughly how many of these pumps have you installed in the UK?
The last time I took a number was, I think, 2018. At that point, we were at 5,500 into the UK market. As a rough estimate, I would expect that to be nearer 8,000 now.
Excellent. Okay. And what looks to be the final question, where can I find more information specifically about selecting pumps?
Yes, so we have a selection tool. It's called Grundfos Product Center. You can find that quite quickly from the Grundfos UK website landing page, and it's quite a self-explanatory selection tool with a simple user interface. So you should find it quite easy to navigate. But please, if you have any questions or want further signposting with links, etc., drop me an email, contact me on LinkedIn. Come into the stand and say hello in the exhibition hall, and I will be more than happy to walk you through it. But if you don't want to do any of those things and you're sick of the sound of my voice, then the Grundfos website landing page points you in that direction quite clearly.
Brilliant. That's great, Ryan. Okay. That's it, I think. So the only thing left for me to do is to thank Ryan for the presentation. Thank you all for attending. The next 2 technical sessions are highlighted on the following slide, and I look forward to seeing you there. Thanks everyone, and goodbye for now.
Thank you everyone. Thank you for your time. Great.